In this video, we will discuss how changes in prices affect the demand. By demand, we mean the Marshallian demand, because we implicitly assume that as the price changes, the consumer's budget/income is held constant. We start with a similar exercise to visualize how the changes in price affect the budget constraint, which then changes the optimal consumption bundle. Let's imagine that the price of good 1 increased, but other things remain constant. So how does the budget constraint move? On this graph, the lighter blue solid curve represents the original budget constraint before the increase in price, and the darker solid curve represents a constraint after the increase in price. For now, we ignore the dash curve, and I'll come back to it on the next slide. So why does a constraint move this way? Well, the Q2 intercept is y over P2. So it won't change at all because the budget remains constant and the price of the vertical good 2 here, also does not change. The only thing that changes is the price of the horizontal good, P1. On the other hand, the P1 intercept becomes smaller because y remains constant, and it is now divided by a bigger P1. And as a result, the slope becomes steeper, with a greater absolute value of P1 over P2. So the budget constraint now rotates around this hinge of the vertical intercept, and the opportunity set becomes smaller. Originally, the consumer is able to choose any consumption bundle under this light blue curve, but now the opportunity set shrinks down to the area below this darker blue curve. And this is intuitive. Although the consumer's budget remains the same as before, as good 1 becomes more expensive, the consumer can no longer afford as many goods whenever it involves consuming any amount of good 1. The optimal consumption bundle changes as the budget constraint rotates. On this graph, the original optimal bundle is marked by the tangent point E1. After the increase in P1, the budget constraint rotates inwards to the darker blue curve, leading to a new tangent point, or optimal consumption bundle of E2. Consequently, as the optimal consumption bundle changes, both demands for good 1 and good 2 change. We refer to this change on demand from the change in price as the total effect, which pushes the quantity demanded for good 1 and good 2 directly from the coordinates at E1 down to the coordinates at E2. It is very useful to think of this effect as a combination of two different effects, which we call substitution effect and income effect. And now let me explain what they are. As P1 increases, two things change simultaneously. First, as good 1 becomes more expensive, it becomes more expensive relative to good 2. In other words, the absolute value of marginal rate of transformation is higher. And this is why the budget constraint is now becoming steeper. Second, as we mentioned just now, the consumer can no longer afford many bundles that were previously available in this area because of the high price of good 1. In other words, the purchasing power of the same budget or income is now lower, as if the consumer is poorer despite the budget or income actually remaining the same. It turns out that the total effect on demand from an increase in price can be decomposed into these two separate changes or effects. First, a rotation from E1 to an intermediate point of E star around the same indifference curve. And then, the second step can be seen as a shift from E star down to E2, where the utility level decreased from the indifference curve at I1 down to the utility level represented by indifference curve labeled as I2. This is a very useful decomposition for intuitive reasoning and for technical purposes. And now let me explain these two effects separately in more detail. First of all, let's take a thought experiment to imagine a scenario where the budget of the consumer isn't really fixed. So even after the increase in P1, the consumer can still use extra resources from elsewhere to reach the original level of utility level represented by this indifference curve of I1. So the question is, would the consumer still choose the original consumption bundle under higher P1? Well, no. Think about our intuition that per dollar utility should be equal at the optimal consumption bundle. As good 1 becomes more expensive, it now provides a lower per dollar utility than good 2. So the consumer will be better off switching away from good 1 and replace it with more units of good 2. This will allow the consumer to reach the same level of targeted utility of I1, but save some money relative to the original consumption bundle under the new prices. To put this differently, if the consumer weren't even limited to a fixed budget and just tries to get the same level of utility as before, they should try to minimize their expenditure. Now, as P1 increases, the price ratio of P1 over P2 becomes higher. So the consumer is now working with steeper expenditure curves, just like this one, the dash curve here, that represents a slope that is consistent with the new price ratio. After the price change, all of the expenditure curves will have the same slope of MRT as the new budget constraint. Now, the lowest expenditure curve that reaches the original indifference curve of I1 is precisely this dashed line, which is tangent with I1 at this point of E star on the graph. In other words, if the budget weren't fixed, the consumer would have chosen consumption bundle E star as opposed to E1 to reach this level of utility. What happens in this hypothetical is that the consumer substitutes good 1 with good 2 because good 1 now offers a lower per dollar marginal utility after the increase in its price. Therefore, to reach the same level of utility, the optimal quantity of good 1 decreases and good 2 increases. Therefore, the move from E1 to E star is being called the substitution effect. It is important to note that our entire thought experiment just now is completely independent of budget. So it only captures the consequences of the price increase that is separate from the issues related to the budget or income. You can think of it as a rotation of the budget constraint or expenditure curve along this original indifference curve to reflect the new price ratio. You might have also realized that the change from E1 to E star is entirely a result of an expenditure minimization problem. So the change in demands from the coordinates at E1 to the coordinates at E star are effectively changes in the Hickson demand function. We will come back to this point a little bit later. A second effect not captured by the previous thought experiment is that the utility level cannot stay the same because the consumer is in fact restricted to the same budget. As good 1 becomes more expensive, it takes more budget or income to afford the same utility as before. Let's compare the point E star with E2. Under the same prices, reaching the original utility level will require more budget. In other words, the consumer becomes effectively poorer after the increase in price, as if the effective income had reduced. If you compare the expenditure curve at E star with the new budget constraint after the price increase, they look like a parallel shift in the budget constraint, as if the budget or income had decreased. We call this change from the intermediate point of E star down to E2 the income effect. On this graph, from the income effect, the demand for good 1 and good 2 both decreased, moving from coordinates at E star down to E2. Using this decomposition, we can think about the effect of the increase in P1 in the following way. From the substitution effect, as P1 increases, good 1 becomes relatively more expensive, so the consumer substitutes good 1 with good 2. If they were able to maintain the same utility level, that is. As a result, Q1 decreases and Q2 increases, and that is the substitution effect that moves from E1 to E star. And independently from the income effect, as P1 increases, the consumer is effectively poorer. In this graph, it appears that both goods are normal goods, and both of their demands decrease as a result of decrease in income. Combining these two effects together, the total effect is that Q1 decreases for sure, and Q2 may increase or decrease depending on which effect is stronger. Here on the graph, we see that Q2 perhaps decreased a little bit comparing to the coordinates at E1, suggesting that the income effect probably dominates the substitution effect, which raises the demand for good 2 in this case. And because overall the effect on good 2 is a decrease, it must mean that the decrease from the income effect for good 2 overwhelms that substitution effect that increased demand for good 2. Whereas for good 1, the substitution effect decreases the demand for good 1, that's represented by this green arrow, and then the income effect further decreases as represented by this darker red arrow here. And combined, the total effect pushes down the demand for good 1 from 24 units to 12 units. In fact, if you think about the Marshallian demand derived from the Cobb-Douglas utility function, one of the most notable features there is that the demand of good 2 does not respond to the price change in good 1 at all. I said back then that we would talk about this intuition at some point. Now you would understand that the underlying reason is that for the Cobb-Douglas utility function, the substitution effect always exactly offsets the income effect for the other good. So although the Hicksian demand from the Cobb-Douglas utility function does decrease in the price of the other good, the Marshallian demand does not. This framework is a very useful tool to help us reason through different scenarios intuitively and get insights about consumer decisions at a deeper level beyond the straightforward law of demand. Let's look at some examples next. One study looked at how consumers in a village in Philippines responded to more affordable cell phone and mobile services. And they found that as the price of mobile services get cheaper, consumers' tobacco consumption actually decreased by a third. Such a dramatic outcome has important implications in public health and policy. But how come the price of mobile services have such a major effect on tobacco consumption? Well, one way to understand this finding through our framework of consumer choices is the following. We can think of a representative consumer choosing between two goods, mobile services and smoking, given a fixed budget, of course. Now, as the price of mobile services get cheaper, we can think through the substitution effect and the income effect. By the substitution effect, mobile services now provide a higher bang for the buck because of its higher per dollar utility. Therefore, the consumer substitutes some cigarette consumption by consuming more mobile services. Meanwhile, there is an income effect. As the price for mobile services decrease, the consumer's budget now has a higher purchasing power. It is as if the consumer is getting richer, and the budget constraint shifts out. As a result, if both goods are normal goods, then the consumption for both mobile services and cigarette will increase. So overall, we would expect the quantity demanded for mobile services to go up, and the quantity demanded for tobacco or smoking will be indeterminate, depending on whether the substitution effect or the income effect is stronger. By showing that the demand for tobacco actually decreased dramatically, the results suggest that within our framework, the substitution effect dominated that income effect. Another study estimates the demand elasticity of cigarettes on youth smoking in 38 different countries to be negative 1.5. But in particular, they found that in relative poor countries, the elasticity is actually higher in absolute value, meaning that demand is actually more sensitive to changes in price. We can imagine in a representative consumer choosing between cigarettes versus all other consumptions. As the price of cigarette increases, the substitution effect leads the consumer to switch away from cigarettes, which is harmful, towards other forms of consumption, and that is a good thing. The increase in price also drives a negative income effect, though, which renders the consumer effectively poorer, and therefore reducing their demand for all the normal goods they have, cigarettes or otherwise. So we expect the demand for cigarette to decrease after the increase in its price. So the negative signs in the elasticity aren't really surprising. But why is the effect on demand stronger in poorer countries? One explanation in our framework is that the same amount of price hike in the price of cigarette leads to a more sizable impact on the purchasing power of the consumers in poorer countries. For example, an extra $10 expense on cigarettes each month may not be a big deal for the average consumer in the United States. But the same $10 increase is going to bite hard into someone's budget in a developing country. So we would expect the income effect to be stronger for those with a lower budget. So the overall effect is stronger due to a stronger income effect in poorer countries. In our framework, the effect of an increase in cigarette prices on the demand for other goods is indeterminate. A substitution effect would increase the demand for these goods, while the income effect would decrease them. So which way it goes depends on which effect dominates. Following this argument, one hypothesis is that for lower income families, the income effect is particularly strong, and therefore we might see that demands for other more beneficial and useful goods will actually decrease after an increase in the price of cigarettes. A different study finds evidence that supports this argument. Bush et al. 2004 found that among the poor, a 10% increase in the price of cigarette caused smoking families to cut back on cigarettes by 9%, which is great. But also they cut back consumption on alcohol and transportation by 11%, food by 17%, and healthcare by 12%. These are worrisome. This evidence suggests that for low-income families in the environment they studied, an increase in the price of cigarette triggers an income effect so strong that actually ended up harming the consumers potentially. We can easily imagine well-intentioned policies that puts extra taxes on cigarettes with the substitution effect in mind. By raising the cost of cigarettes, you would hope to navigate consumers to switch away from it. But the income effect can potentially bite back and ended up harming the consumers, especially those with lower income. You frequently hear about the unintended consequences of well-intended policies. And in this case, it can easily be understood through our consumer's choice framework that sheds some light on the complex issues related to policy, inequality, and social welfare. I will note one important observation revealed here through these examples. The observation is that the strength of the income effect usually depends on the level of income or budget. We will formalize this idea later in the section, so please hold on to this idea. Now at this point, I would like to deepen our understanding of the substitution effect and income effect through two special cases that are somewhat extreme. The first one is the case of perfect complements. Let's use the textbook example of ice cream and pie again. Suppose that the consumer has to consume these goods in perfect proportions. Then intuitively, is it possible for the consumer to substitute pies with ice cream when pies becomes more expensive? Well, not really, because these two goods cannot be substituted between each other at all. So similar idea holds if you think about our example of bicycle frames and wheels. Even if wheels get more expensive, you can't really get away with buying less wheels and more frames. In this situation, because these two goods cannot be substituted between each other, there is going to be no substitution effect. So the only effect that drives the response in demand will be the income effect. And we can verify this intuition from a more technical analysis on this graph. This flatter, lighter budget constraint represents the original budget constraint when the price of the pie was lower. And the optimal consumption bundle is at E1, which reaches the indifference curve I1 at its corner. Now, as the price of pie increases, the budget constraint rotates around the vertical intercept inward down to the darker budget constraint. And the slope becomes steeper because the price ratio of the horizontal good over the vertical good is now higher. And now let's think about the substitution effect, where the consumer tries to reach the same level of utility represented by the indifference curve of I1 after the price change. Now, at the new price ratio, that is represented by the slope of the new budget constraint and also this expenditure curve, the lowest possible expenditure curve that will reach the indifference curve I1 will be here. And inevitably, it will be landing at this corner of the indifference curve. However, just like the original budget constraint, the optimal consumption bundle E star still lies at the corner of the indifference curve. So the expenditure minimizing consumption bundle with new prices is exactly the same as the original bundle of E1. And we see that there is no substitution effect at all. Therefore, the overall effect that changes the consumption bundle from E1 to E2 is entirely driven by the income effect. In this case, both goods are normal goods. So from the income effect, the demand of both goods decreases, and this is the overall effect. Our second special case is the case of Giffen good. So far, we only considered normal goods when it comes to the income effect. If the price of a good decreases, its demand increases from the substitution effect. Moreover, the consumer is effectively richer, so the income effect leads to a higher demand for the good as well. So overall, the demand for the good definitely increases. Well, how would all this analysis change if the good is an inferior good instead? We know from our previous video on the effect of income on demand that for an inferior good, its demand actually decreases if the consumer becomes richer. As a result, if the price of an inferior good decreases, then its demand increases from the substitution effect, just the same as the case of a normal good. However, the income effect is now different. As the consumer becomes effectively richer, the demand actually decreases from the income effect. So overall, the total effect on the demand becomes ambiguous. In an extreme situation, if the income effect is particularly strong, it becomes theoretically possible that the demand can actually decrease when its price decreases. Now, this is totally contrary to the law of demand. Economists have long been curious about the possibility of finding a good with such behavior. This hypothesized good is called a Giffen good, and the behavior where the demand increases as its price rises or the demand decreases as its price drops is called the Giffen behavior. This behavior can be explained by our perfectly rational framework. It is the combination of the inferior good with a strong income effect. You might wonder, if a good exhibits Giffen behavior, does it mean that our model failed? Well, the answer is not at all. If you think back to our setup of the model, we never assumed the law of demand would hold, or the consumer will respond to a higher price in any particular way. We simply think that the law of demand is a phenomenon that seems to be true in most situations. So it would be intuitive if the demands we derive from the model exhibits this property. Indeed, the demands derived from the Cobb-Douglas utility function or CES utility function all exhibit law of demand. But we never imposed it as part of the consumer's choice model. In fact, I would argue that through the given behavior, the model actually reveals a hidden logic that the law of demand might not be true, and offers a totally intuitive explanation for it. So do we actually have any evidence of the given behavior in reality? Well, two economists actually recently documented such an example in Jensen and Miller 2008, and we will discuss this paper in class. So in this video, we learned about the intuitive way to decompose the effect of a price change on demand. The changes in the Marshallian demand can be decomposed into a substitution effect and an income effect. The substitution effect is entirely captured by the expenditure minimization problem under the new prices. In other words, the Higginson demand captures the substitution effect. In the next video, we will further explore the connection between these two types of demands.